5.3, we are going to take a look at the reverse of what we've been looking at so far in this normal distribution unit. So think about this first question. What if you know the probability and you wanted to find the z-score of a data point? Write 5 lines about how you would solve this problem. So an example here would be to find the z-score that corresponds to a probability of 0.22956. Okay, so pause the video for a little bit and think about how you would find that z-score, and then restart the video. In this section, we'll learn a couple of different ways to find the z-score for a given probability value, but one of the easiest, especially for right now, is to take a look at your standard normal table. So inside of the table are the probability values, and along the outside are the z-scores. So I can look for 0.22956 inside the probability table, and let's take a look here. 0.22956. There it is. Right? So there's our probability value, 0.22965, right? And that would correspond to a z-score of negative 0.74. Right? Right, so that corresponds to a negative 0.74 by looking up the probability value value inside that table and recording the corresponding z-score. All right, so let's go on to the notes for today, which is all about finding the data values given probabilities. All right? So there's 2 steps we need to do in order to find the data values. The first step is find the probability inside the standard normal table and record the corresponding z-score. Or we can use the calculator. The calculator has an inverse normal function. Okay. You would find this in the same location. You'd hit second and then the distribution menu, and this would be option number 3. And we can just type our probability value in here, and the calculator will give us the corresponding z-score. After we have the z-score, we need to do step 2, which is convert the z-score to a data value. Right, I'm going to do a little side calculation over here. We know our z-score formula is our data value minus the mean divided by the standard deviation. So now if we want to find the z-score, if we want to find the data value when we're given the other 3 values, the z-score, the standard deviation, and the mean, right, let's just solve this formula once, and then we'll have it set for whatever we need. So in solving this formula, the first thing I can do is multiply both sides by the standard deviation. So I have z-score times the standard deviation equals our data value minus the mean. Then I can add the mean to both sides. So I end up with z-score times the standard deviation plus the mean will equal our data value. So I'll write that formula over here. Okay. And the calculator, once again, can save us a whole lot of time by doing all of this at once. And this would be using the inverse normal function. You can enter the p-value, and just like with the normal CDF function, the calculator assumes that if you just give it the probability that we're talking about the standard normal distribution. But if we specify a different mean and standard deviation, the calculator will automatically give us the data value. All right, so going on to the first example, all right, we want to find the z-score that corresponds to a cumulative area of 0.7737. Right, now we could do this just by looking at the chart. If I pull the probability table up, scrolling down to 0.7737, it's right here. So this would be 0.75. So our z-score equals 0.75. Right? We could also do this on the calculator. Since it's only asking for the z-score, we just enter inverse normal and type in the probability. Now the nice thing about the calculator is not all of these probability values show up on the standard normal distribution table. The calculator will find the z-score, whereas if we're using the table, we might have to estimate a little bit. Right, in example 2, find the z-score that corresponds to a cumulative area of 0.00150. So if we go right to the calculator, we want the inverse normal function, 0.00150. And this gives us a z-score of negative 2.97. Right? So our z-score is negative 2.97. Now example 3 says to find the value at the 63rd percentile in a data set with a mean of 23 and a standard deviation of 6. When we talk about the 63rd percentile, we're talking about p equals 0.63. All right, percentile values mean that 63% of the population fall below that data value, so that just equals our p-value. Right, so we have a mean of 23 and a standard deviation of 6. So we can do inverse normal 0.63 comma 23 comma 6, and this will give us the data value x equals 24.98. Right. Now on to the next example. The average time spent sleeping in hours for a group of medical residents at a hospital can be approximated by a normal distribution with a mean of 6.1 hours and a standard deviation of 1 hour. So what is the shortest time spent sleeping that would still place a resident in the top 5% of sleeping times? Right? Now, this problem is a little bit different, right? Because if we look at the normal distribution, the top 5% would be over here. Very small probability up there, right? 0.05. So if this probability or this area is 0.05, the area to the left, the area below, would be 0.95. So our p-value here is actually 0.95. So our mean is 6.1, and our standard deviation is 1. So we can use the inverse normal function with p-value of 0.95, mean of 6.1, and a standard deviation of 1. And then whenever we enter that into the calculator, let's see here, we get a data value of 7.74. So we would say sleeping 7.74 hours or more would place someone in the top 5%. So they're getting a lot of sleep compared to others. So now try the last 3 practice problems here. Pause the video to try them, and then restart the video. Check your answers. Right. Here in problem number 5, we're just looking at what z-score has 4.91% of the distribution's area to its right. Right. So keyword to its right. Just like example number 4, right, if that's the area to the right, we need to find the area to the left, right? So just subtract from 1, right? And that will equal 0.5909. So our p-value here is 0.5909 because we have to consider the area to the left. We're just finding z-score here, so use the inverse normal, 0.5909, and this gives us a z-score of 0.23. In practice problem number 6, we want to find the value at the 50th percentile in a data set with a mean of 36 and a standard deviation of 8. Now, as we work through this problem, the answer should not be a surprise. Right? So, percentile of 50, or 50th percentile, corresponds to a p-value of 0.5. We have a mean of 36 and a standard deviation of 8. So using the inverse normal, 0.5, 36, and 8, we get our data value to be 36. And this should not be a surprise because the mean is in the middle of the data set. Right? That is the 50th percentile. So we could have written 36 without doing any of the other work here. And finally, on number 7, as we look at the mean number of days waiting for a heart transplant, a mean is 224, standard deviation is 30, and we want the lowest 5%. So our p-value is 0.05, right? 5% is 0.05. Our mean is 224, and our standard deviation is 30. So let's do the inverse normal. 0.05, 224, and 30. This gives us a data value of 184.65. So we could round this up and just say about 185 days would be in the lower 5%. So that would be a short waiting period for this. All right. So that's all there is to this section. We will do some more practice problems with this over the next 2 days just to get this solid before moving into the next section.